Python basics with code examples. Python as a programming language is very useful in the building of models and execution of projects in the science and technology industry. Python, among other programming languages like Java, JavaScript, C++, is very versatile and it has much functionalities which helps in tackling and solving computational problems. Python, due to its versatility, is very useful in data science, machine learning, and artificial intelligence. Python has more libraries in it which find it easy in building models suitable for data science and analytics problems. Well, for the sake of this topic, we'll be focusing on the Python basics necessary for a good Python program. These basics are in the slides below. Now, let's look at strings and integers in Python. We are going to come from a mathematical view of it because there are always a relationship between mathematics and computer programming. So if we are coming to treat strings and integers from a mathematical view, using the number 4 as an example, we all know that 4 is an example of a numeric value. In mathematics, 4 is an integer value. Integers are whole numbers, which means they have no fractional parts, and they can be positive, negative, or 0. Examples of integers can be 4, minus 19, 0, minus 3, 2. All of those examples are examples of integers in mathematics. In contrast, 4.5 is not an integer, since it is not a whole number. Now, Python supports a number of numeric and non-numeric values. In particular, Python programs can use integer values. The Python statement print 4 only prints the value 4. The value 4 is an example of an integer expression in Python. Python supports other types of expression besides integer expressions. So apart from an integer expression, we have other expressions that Python also supports. What is an expression? An expression is a basic building block of a Python statement. Python recognizes both single quotes and double quotes as valid ways to delimit a string value. The word delimit means to determine the boundaries or limits of something. The left single symbol determines the beginning of a string, and the right quote symbol that follows specifies the end of the string. If a single quote marks the beginning of a string value, a single quote must delimit the end of the string. Similarly, the double quote, if used instead, must appear in pairs. You may not mix the two kinds of quotation marks when used to delimit a particular string. Now, what are we trying to say here? Let's take a good look at these lines of code. Here is an expression ABC. This ABC is inputted within two quotes, a single quote starting it and a single quote also ending it. When you input this into Python understands it and also print it as a string value. This second one is an expression ABC with double quotes and also ending with double quotes. When you input it, Python understands it as a string and it gives a result as a string value. Now, going to the next line, we are starting with a single quote and we are ending with a double quote. Because you are starting with a single quote and you are not ending with a single quote, this automatically prompts an error. So there is a rule when it comes to strings that when it comes to strings, all expressions being expressed must be start and end with same quotes. So if you are using single quotes to start, you must end with a single quote. If you're using double quote to start, you must end with a double quote. So when in this case you use a single quote in starting this expression and end with a double quote, Python prompt an error, and you can see here syntax error. Now let's take a good look at the number 19. We talked about the integer number 4 in the previous slides, and we did not really make much emphasis. Here we are going to make much emphasis on integers. 19 is an integer just like 4 is an integer. 19 in mathematics is an integer, and when you input 19 as an integer also in Python, Python also understands it to be an integer, and Python will also return it to be an integer value for you. Now in Python, when you enclose or input your 19, which mathematically is an integer, when you input it in Python with 2 double quotes or 2 single quotes, Python automatically sees this not as an integer, rather to be a string. So a mathematical integer value like 19 enclosed with double quotes or single quotes in Python cannot or will never be seen as 19. Rather, it will be seen as a string. So Python is always seeing this 19 within this quote as an integer. Rather, it is seen as a string. That's why when you input this and you run it, you're getting your result in form of a string. The same thing appears to here, you are getting that in form of a string. Then apart from integers, Python also makes use of some expressions which can come from the English alphabet, like you name Fred. Fred, when enclosed with the double quote, Python understands it to be a string. So Python, provided the double quote or the single quote is there, Python understands it as to be a string. But when you run Fred on its own without a quote, Python runs into an error telling you name error. The name Fred is not defined. Now, notice that with the missing quotation marks, the interpreter does not accept the expression Fred. It is important to note that the expressions for and for in quotes are different. One is an integer expression, which is the for here, and the other is a string expression, which is the for enclosed with a quotation mark. All expressions in Python have a type. The type of an expression indicates the kind of expression it is. An expression's type is sometimes denoted as its class. At this point, we have considered only integers and strings. Python associates the type name int with integer expressions and str with string expressions. So if you have your inbuilt functions, you don't really see Python giving you a full name as integer or a full string. What you see there is int and str, that is int and strings. The built-in function creates an actual integer object from a string that looks like an integer, and the str function creates a string object from the digit and make up an integer. Also, when dealing about strings and integers, commas may not appear in Python integer values. We all know that in mathematics, the number 2468 will be written as 2468, separated with a comma. But in Python, this number will be written as 2468, not 2,468. In mathematics, integers are unbounded. That is, in another way, we can say that the set of mathematical integers is infinite. But in Python, integers may be arbitrarily large, but the larger the integer, the more memory required to represent it. Now, let's move to variables and assignments in Python. We are also going to come from the mathematical view of it and draw it back to the computer programming background, because there is always this relationship between mathematics and programming. We all know that in algebra, variables represent numbers. The same is true also in Python, except in Python, variables also can represent values other than numbers. The example below uses a variable to store an integer value and then print the value of the variables. Now, let's take a good look at this example. This is x. Mathematically, this is x equal to 10. In mathematics, we have this sign to be an equality sign, which means that this x equals to this number 10. So when you print x, this automatically in mathematics, once you see x, we know that x is what? 10. But when it comes to the programming view of it, this means that x is assigned to the value 10. So inside x, you will see 10. So if you print x, it will give you 10. Now, this example contains two statements. It contains this variable x and 10, and it also contains an assignment statement, which is this equals sign. This is an assignment statement. An assignment statement associates a value with a variable. The key to an assignment statement is the symbol equal to sign, this symbol, which is known as the assignment operator. So in Python programming, this equal to sign in mathematics, this equality sign is known as the assignment operator. The statement assigns the integer value 10 to the variable x. So in this case, you can see it's assigned the integer variable 10 to this variable what? X. If said another way, this statement binds the variable named x to the value 10. At this point, the type of x is integer because it is bound to an integer value. So when you print x automatically, because it has been bound to the number 10 we know is an integer. So once you print x automatically becomes an integer type of value, which is 10. We may assign and reassign a variable as often as necessary. The type of a variable will change if it is reassigned an expression of a different type. The statement prints the variable current value. So if you print x will still print 10. But if you come and assign a new variable to x prints the new variable. What are we trying to say? Let's take a good look at it. The meaning of the assignment operator is different from equality in mathematics. In mathematics, the equality sign asserts that the expression on its left is equal to the expression on its right. But in Python, that sign makes the variable on its left take on the value of the expression on its right. Now, it is best to read x equals to 5 in Python as x is assigned the value 5 or x gets the value 5. This distinction is important since in mathematics, equality is symmetric. Now, let's look at the example below. If x equals to 5, mathematically, we know 5 equals to x. But in Python, this symmetry does not exist. The statement 5 equals to x attempts to reassign the value of the literal integer value 5, but this cannot be done because 5 is always 5 and cannot be changed. So such a statement will always prompt an error when it comes to programming, because x equals to 5, that is symmetric, but when it comes to programming, 5 cannot equals to x. Let's see. X equals to 5. If you print x in programming, this means x is assigned a value 5. So 5 is inside x. So if you print x, you will see 5. But when it comes to this condition, 5 assign the value x. This will surely prompt an error, which you can see syntax error. Can't assign to what? Literal. We can reassign different values to a variable as needed. If you assign x to 10, it means 10 is inside x. So if you print x, you will get the value 10. Now, if you assign a new value 20 to that same x, when you print the x prints 20. If you assign a new value again to that value 30, to that value x, which is 30, and you print the x print 30. What does it mean? This means that Python run its code line by line. So what we are just trying to say about variables and assignment statements is that most of the symmetry that exists between in mathematics is surely somehow different from what's really happening in the programming world. So x equals to 10 mathematically, 10 suppose also equals to x, but when it comes to programming, x equals to 10 cannot be 10 equals to x. So in programming, there is always some little relationship differences that does not really follow some rules of mathematics. Programmers generally avoid distinguishing between two variables in the same context, mainly by differences in capitalization. Doing so is more likely to confuse human readers. For the same reason, it is considered poor practice to give a variable the same name as a reserved word with one or more of its letters capitalized. The most important thing to remember about a variable's name is that it should be well chosen. A variable's name should reflect the variable's purpose within the program. For example, consider a program controlling a point of sale terminal, also known as an electronic cash register. The variable keeping track of the total cost of goods purchased might be named total or total cost. So if you are trying to write a program that is about electronic cash register, you can choose to use the variable name to be total cost. This total cost tries to give a good view about what you are trying to code with. But if you come and use names like A67_99 or you try to use names like Fred, this will be a very poor choices for such an application, because when you look at this, you cannot really get a good information about what you are recording of. So programmers try to make good use of names that are in line with the logic of their programs. Now let's look at tuples in Python. A tuple is a comma separated list of expressions. If the variables total and s are defined, the expression total 45 s 0.3 represents a 4 tuple. That is a tuple which composed of 4 elements in the assignment statement. Now let's look at, we have a set of tuple here. We have x, y, z assigned to 100 minus 45, 0. This means that x is assigned to the value 100, z is assigned to the value minus 45. That's y. Z is assigned to the value 0. So z take 0, y take minus 45, z take, x take 100. XYZ is one tuple, and 100 minus 45, 0 is another tuple. Tuple assignment works as follows. The first variable in the tuple on left side of the assignment operator is assigned the value of the first expression in the tuple on the left side. Hence, effectively, x equals to, or x is assigned to 100. The same thing happens to the second one, y assigned to minus 45 and z assigned to 0. Tuple assignment works only if the tuple on the left side of the assignment operator contains the same number of elements as the tuple on the right side. What does that mean? Considering this very example, x, y, z assigned to 45, 3. If we check on the left tuples, we have three variables here, x, y, z. On the right, we have 1 and 2, that is 45 and 3. This will surely prompt an error because for two tuples to work effectively in the Python environment, this x takes the value of 45, y takes that of 3, so z suppose have a number which should also be assigned to, but in this case that wasn't provided, hence it will prompt an error. And that's why if you come here, you see a value error. You need more than two values to unpack. Similarly, if you also have set of two tuples where you have x, y, z assigned to 45, 3, 23, 8. If you look at the right hand side, we are having 4 values here, and if you look at the left hand side, we are having 3 variables. This also means that it also prompts an error, since x will be assigned 45, y will be assigned 3, z will be assigned 23, but it does not have a variable here to be assigned to, hence there will be a value error, which is too many values to unpack. A tuple is a kind of Python type like int or float. Now let us look at identifiers in Python. While mathematicians are content with giving their variables one-letter names like x, programmers should use longer, more descriptive variable names. We all know that mathematicians always like using x. The English alphabet can be y, z, in trying to use it as variables in their mathematical computation. But let's see what really happens in computer programming, especially in Python. Names such as sum, height, and subtotal are much more better than the equally permissible s, h, and st. So while mathematicians are using single variables like x in their mathematical computation, programmers are trying to make use of names like sum, height, subtotal, something that tries to give some little information about the logic of their program. Good variable names make programs more readable by humans. Since programs often contain many variables, well choosing variable names can render an otherwise obscure collection of symbols more understandable. Python has strict rules for variable names. A variable name is one example of an identifier. An identifier is a word used to name things. One of the things an identifier can name is a variable. Now, identifiers can name things such as functions, classes, and methods. Identifiers have the following form. 1. An identifier must contain at least one character. 2. The first character of an identifier must be an alphabetic letter, either in upper or lowercase, or with the underscore. So, an identifier can take either a capital letter from A to Z and small letters from A to Z, and also with an underscore. Now, the remaining characters may be alphabetic characters, either upper or lower case. No other characters are permitted in identifiers. A reserved word cannot be used as an identifier. Examples of valid Python identifiers include x, x2, 22, but underscore 22. Now, we have reserved word in Python, and this reserved word in Python, they cannot be used as identifiers. For example, like class, you cannot use class as an identifier when you are trying to write a simple set of code. You cannot make use or some of these statements like pass to be an identifier because already they are inbuilt Python reserved words. Now let's look at Python floating point numbers. Many computational tasks require numbers that have fractional parts. For example, to compute the area of a circle given the circle's radius, we use the value pi. And pi we all know is approximately 3.14159. Python supports such non-integer numbers, and they are called floating point numbers. Now, this implies that during mathematical calculations, the decimal point can move or float to various positions within the number to maintain the proper number of significant digits. The Python name for the floating point type is float. Now, what are we trying to say here? We all know that in mathematics, fractional and decimal values are always very useful and are accepted. Also, in Python, this mathematical concept is also introduced, but Python sees them to be what? A floating set of numbers. In mathematics, we know that when we are dealing with significant figures, a number like 3.1459 can have its decimal points floating from one place to another depending on the number of significant figures. But in Python, the Python sees it to be a float and we call it a floating type of number. Now let's look at what really happened to floats. Taking a good look at this, x is assigned the number 5.62. So once x is assigned 5.62, so if we print x will give us 5.62. The type of this 5.62 is a what? It's a float. A float, not even an integer, because this is a fraction, it's at a fractional part. So it is a float. So Python is not seen as an integer, rather Python is seeing it as what? A float. The range of floating point values, both positive or negative, and precision depends on the Python implementation for a particular machine. Floating point numbers can be both positive and negative. As you can see, unlike Python integers, which can be arbitrarily large, floating point numbers have definite bounds. Let's look at the example below, which prints an approximation of the mathematical value pi. Now, we tried to introduce a variable here, pi, and in pi, we assign the value of pi, which is 3.14159. So if you run a program, a small print statement, print pi equal to pi. So this pi is taking the value 3.14159. Remember what is here? This is simply like a string. So if you print that, or you can print 3.14 for short. Once you print this, Python automatically prints the value of pi, which is 3.1459. Let's see. The first line in the example above, which is this, assign an approximation of pi to the variable named pi. And the second line, print its value. That is this line. It's print its what? Value. The last line prints. The last line also print what? 3.14. So floating point number are very important in Python because Python sees them to be different from integers, and we know mathematically numbers cannot always be whole numbers, some will always be fractional. So Python sees those fractional parts of numbers as floats, and they are very useful in Python programming. Now let's look at conditional execution. All the programs in the preceding slides execute exactly the same statement regardless of the input, if any, provided to them. They follow a linear sequence. Statement 1, statement 2, that's all that we are looking at before until the last statement is executed and the program terminates. What are we trying to say? If you look at this very particular set of program, Python will first of all print X, and if there's another lines of code here, Python will have to what? Print this before it prints the next one. Python prints code line by line. Linear programs like these are very limited in the problems they can solve. This concept introduces constructs that allow program statements to be optionally executed, depending on the context of the program's execution. Arithmetic expressions evaluate to numeric values. A Boolean expression, sometimes called a predicate, may have only one of the two possible values, false or true. The term Boolean comes from the name of the British mathematician George Boole. A branch of discrete mathematics called Boolean algebra is dedicated to the study of the properties and the manipulation of logical expressions. While on the surface, Boolean expressions may appear very limited compared to numeric expressions, they are essential for building more interesting and useful programs. The simplest Boolean expression in Python are true and false. Now, let's take a good look at the following set of code. In the Python interactive shell, we see true. This true is an example of a Boolean expression. Print it, it gives you true. Python recognizes it. False give you false. And the type of true, when you run it on the Python, it tells a bool. That's a Boolean type of expression. You can see false is also a Boolean. So we see that bool is the name of the class representing Python's Boolean expressions. We have seen that the simplest Boolean expressions are false and true. The Python Boolean literals. Now, a Boolean variable is also a Boolean expression. An expression comparing numeric expressions for equality or inequality is also a Boolean expression. The simplest kinds of Boolean expressions use relational operators to compare two expressions. An expression like 10 less than 20 is legal but of little use, since 10 less than 20 is always true. The expression true is equivalent, simpler, and less likely to confuse human readers. Since variables can change their values during a program's execution, Boolean expressions are most useful when their truth values depend on the values of one or more variables. Now let's see what happens in this Python interactive shell. We said X is assigned the value 10. So if you print X, you have the value 10. X is less than 10. We all know that X was assigned 10. So if you run a code that X is less than 10, then Python will tell you it's false. It is false because we all know that X have 10. So since X was assigned the value of 10, X cannot be less than 10. Hence, it is what? False. Now, if you also run it like X is less than or equal to 10, Python gives you this to be what? True. Because this condition tries to satisfy the fact that X is assigned the value 10. If you also run it that X is greater than or equal to 10, Python also run it to be true. The same thing happens when you run it that X equals to 10. Now, this double equality sign in Python means the equality sign in mathematics. So why in mathematics they are having just one equals to sign, one equality sign, like just equals to s equals to 10, in Python we represent it to be x equals 10. So this means s equals to 10. So Python, we understand it to be what? True. It is true because x is assigned the value of 10, hence x equals to 10. If you run it that x is greater than 10, it will give you false because we know that x here is assigned the value of 10, hence x cannot be what? Greater than 10. But we know that that x which was assigned the value of 10 is less than 100, so that is what? True. That x which was assigned the value of 10 is less than 5, it is what? False, because 10 is not less than 5, hence it is what? False. So this is how we try to play with Boolean expressions. Boolean expressions always make use of true or false. The first input in the shell binds the variable x to the value 10. The other expression experiments with the rational operators. Exactly matching their mathematical representations, the following expressions are all equivalent. So you can look at these following expressions: x less than 10, 10 greater than x. If you look at these two, they are almost the same thing. We know that x is less than 10. So if x is less than 10, that means 10 is greater than what? X. Yeah, okay. The relational operators are binary operators and are all left associative. They all have a lower precedence than any of the arithmetic operators. Therefore, Python evaluates the expression x plus 2 less than y divided by 10 as if parentheses were placed as so. So Python will see it to be x plus 2 less than bracket y over 10. Let's look at the if statements. The Boolean expressions described earlier on at first may seem arcane and of little use in practical programs. In reality, Boolean expressions are essential for a program to be able to adapt its behavior at runtime. Most truly useful and practical programs will be impossible without the availability of Boolean expressions. The execution errors mentioned earlier arise from logic errors. One way that this can fail is when the user enters a 0 for the divisor. Fortunately, programmers can take steps to ensure that division by 0 does not occur. Now let's look at the example below. The general form of the if statement is a conditional word block. If. So we want to have an if statement, we normally start with a conditional block. If. So if we quickly go to look at some line of code about that if statement tries to give some kind of conditional logical operation to a set of code. So if x is less than 10 and y is assigned x, this could be written as if x is less than 10 colon y assigned x. Now, what is the logic about if statement? If statement always occur when there seems to be a kind of a double thought about a particular logic. For example, if x less than 10, then I can say print x equals to 2 because I know x is what? Less than what? 10. If I said x is assigned 2, so if x is less than 10, which is 2, if you print x, it will surely give me 2 because we already know that x is less than 10. So if statement tries to prompt a conditional statement to what we are trying to do. Now, conditional statement always take note of the spaces provided. So it's very important when we are doing our if statement, we also take note of the indentation that we are trying to do. Then let's look at the if-else statement. The if statement has an optional else block that is executed only if the Boolean condition is false. The example below uses the if-else statement to provide the desired effect. Now, let's look at these lines of code. Dividend assigned to int input, please enter the number to divide. These lines of code is just trying to let us know that if the divisor, the number we are trying to divide here, is not equal to 0, then print the dividend. S, if it's equal to it, print division by 0 is not allowed. So there are two thoughts here. If it is not equal to 0, you print this, but x, if it is equal to 0, you print what? This. So if and else conditional statement always comes when there are double thoughts about a particular logic in a set of code. So let's go to the past statement. Some beginning programmers attempt to use an if-else statement when a simple if statement is more appropriate. For example, in the following code fragment, a programmer wishes to do nothing if the value of the variable x is less than 0. Otherwise, the programmer wishes to print x value. What are we talking about? In this line of code, if x is less than 0, do nothing. If we say do nothing, this is just a comment. If we do not, like this will not work in Python. See s print x. Past statement is a kind of a reserved word we already have in Python. So when we don't actually want our program to do nothing, we can just simply input the word, the reserved name pass, and the program will just pass that very line of code. We don't want it to do anything. Let's look at an example here. If x is not equal, is less than 0, pass. This pass means what? Do nothing. So once Python reads this and comes to this, once it see pass, it ignores this and go back to what? X, print x. So while the pass statement makes the code legal, we can express its logic better by using a simple if statement. It is to be noted that Python programming language is very fast, and trying to cover all its basics and functionalities will be very voluminous. Other Python concepts like functions, libraries, class, and more exist, which are very useful and important in Python. The Python basics explained and treated above are very important and necessary for understanding Python. This, if well understood, can be employed in tackling and solving data science and analytical problems. Python is one of the programming languages easy to learn. Hence, mastering its basics will be a powerful tool in the journey of understanding coding in Python. It will be very, very helpful when there are good mathematical background and being imbibed into Python. So when you are good and sound in your mathematical background and you try to bring that knowledge into programming background, you find this very easier. Python is one of the programming languages that is very, very useful in the present day world, which most of the science and technological field are using. So it is very, very nice when you learn most of the basics in Python and you use it in trying to solve most of your problem. And that's why it's those in data science field, those doing data analytics, machine learning, deep learning, artificial intelligence, the mix of Python, because the versatility of Python and how unique and versatile that it is makes it very, very possible for them to import most of the libraries in Python in making good use and trying to solve most of their problems. And this cannot work when they don't have good Python basics. So knowing the basics of Python is very, very important. And this very particular video and class is here to give you most of your concepts and knowledge about the basics of Python. So I'm very, very sure that by the end of this class, you'll be able to on your own, get some good clips about Python basics. Thank you.